students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as differential equation. Let's see the sum. Small x e raised to minus y dx plus y dy is 0. Right? I have to form a differential equation. So I need to get x together, y together and integrate. So this is going to be x e raised to minus y dx is minus y dy. This can be written as x dx is equal to minus y upon e raised to minus y dy. This can be written as x dx is equal to x dx is equal to minus y e raised to y dy. Right? Now integrate both sides. If I integrate, I'll get integral of x dx is nothing but minus integral of y e raised to y dy. Integral of x dx is nothing but x square by 2 plus c minus, as it is here, you will use parts. Y is algebraic, e raised to y is exponential. So u integral of v minus integral of v derivative of u dx. Right? So this can be written as x square by 2 plus c is minus y e raised to y, integral of e raised to y is e raised to y, minus into minus plus integral of e raised to y dy, because v by dy of y is 1. So I'll get x square by 2 plus c is minus y e raised to y plus e raised to y. Right? Let's see the next sum, guys. I can say that x dx plus sec x dy is 0. You have to form a differential equation and you have to solve the differential equation and find the particular solution. Find particular solution when y is equal to 0 and x is equal to pi by 2. Right? Now, they've given you that x dx plus sec x dy is 0. Therefore, I can say that x dx is equal to minus sec x dy. So therefore, I can say that x upon sec x dx is equal to minus dy. Right? X together, y together, integrate. So integrate this and integrate this. So in that case, you will get this as integral of x cos x dx is minus integral of dy. Now this is going to be parts where x is algebraic and cos x is trigo. Right? Algebraic comes before trigo. So in that case, u integral of v minus integral of v derivative of u dx is equal to minus integral of dy is y. Okay, so this can be written as x. Integral of cos x is nothing but sin x minus integral of cos x is nothing but sin x. Dy dx of x is 1, dx is minus y. Now this can be written as x sin x minus integral of sin x is minus cos x plus c is minus 1. Right? Now but they give you that value of y is 0 and x is pi by 2. Substitute these values here. So in that case, you will get pi by 2 sin pi by 2 plus cos pi by 2 plus c is 0. This is pi by 2 sin pi by 2, sin 90 is 1, cos pi by 2, cos 90 is 0 plus c is 0. Therefore, I'll get c is minus pi by 2. right? Now substitute the value of c in your differential equation that you have formed. So I can therefore say that x sin x plus cos x plus c. Instead of c I can write minus pi by 2 is minus pi is the particular solution. That is how you find a particular solution to the given problem. And do we get this in here? Let's see another sum. Y 1 plus log x dx by dy minus x log x is 0. And they've said find particular solution when x is e. Find particular solution when x is equal to e and y is equal to e square. Right? Let's see this. They've given you the sum as y 1 plus log x dx by dy minus x log x is 0, right? Now I can therefore say that y 1 plus log x dx by dy is equal to x log x, right? In which case I can therefore say that 1 plus log x upon x log x dx is equal to nothing but 1 upon y dy, right? Here integrate both the sides. You will say let x log x equal to t, differentiate with respect to x. If I differentiate with respect to x, I'll have to use uv formula. V derivative of u plus u derivative of v is dt by dx. Therefore I'll get log x plus x. d by dx of log x is 1 upon x is dt by dx. So I'll get 1 plus log x is dt by dx. Therefore I can say that dx is equal to 1 upon 1 plus log x into dt, right? Now once you have this, I can therefore say integral of 1 plus log x upon t dx can be written as 1 upon 1 plus log x dt is integral of 1 upon y dy. Cancels. Integral of 1 upon t is log mod t. Integral of 1 upon y is log y. Now since both the terms x and y are in terms of log, you will have to have your constant also in terms of log, right? Now I can say that therefore log tc is equal to log y. Log and log gets cancelled, therefore I can say tc is equal to y. I can substitute the value of t. I can therefore say that x log x into c is y. Therefore c is y upon x log x, right? Once you have this, then you can say, but they've given you that the value of x is e and y is e square, right? Substitute, therefore I'll say c is equal to e square upon x is e log e. E and square gets cancelled, so I'll get c is equal to e. Log e we know is 1. The value of log e we know is 1, so c will be equal to e. Therefore I can say that e is equal to y upon x log x is the particular solution. Next, let's see another sum, guys. X plus 1 dy by dx plus 1 is equal to 2e raised to minus y, when x is equal to 1 and y is equal to 0. Right, let's see this. I can say that x plus 1 dy by dx is equal to 2e raised to minus y plus 1, no, not plus 1, this will be minus 1. Right? Once you have this, then I can therefore say that 1 upon 2e raised to minus y minus 1 dy is nothing but dx upon x plus 1, cross multiply. Now, this can be written as integrate both the sides. Integral of 1 upon 2 upon e raised to y minus 1 dy is integral of dx upon x plus 1. Now, if I take LCM, I'll get this as integral of e raised to y upon 2 minus e raised to y dy is equal to integral of dx upon x plus 1. Right, LCM I have taken, and the denominator of denominator becomes numerator. Now, I'll say that we know that d by dx of 2 minus e raised to y is minus e raised to y. So I'm going to put a minus sign outside and a minus sign inside, so that I can make the numerator to be the derivative of the denominator. Integral of dx upon x plus 1. Now, minus. The term in the numerator is derivative of the denominator, therefore this is going to be log mod denominator. This is again integral of 1 upon ax plus b is 1 upon a log mod ax plus b. So this is going to be log of x plus 1. Since both the x and the y terms are in terms of log, you will write your constant also in terms of log. Yeah. Yeah. Log c. Right? Now, in order to get rid of the negative sign, this will become log of 1 upon 2 minus e raised to y is log of c into x plus 1. Log and log gets cancelled, so 1 upon 2 minus e raised to y is c into x plus 1. Right? Once you have this, but they've given you that x is 1 and y is 0. So this will be 1 upon 2 minus e raised to 0 is c 1 plus 1. Anything raised to 0 is 1. So this will be 1 upon 2 minus 1 is c into 2. 1 is equal to 2c. Therefore c is 1 upon 2. Substitute this back in the original equation. Therefore you will get this as 1 upon 2 minus e raised to y is 1 upon 2 x plus 1 is the particular solution. Right, next let's see another sum. Y minus 3 is equal to x 3x plus 1 dy by dx. Find particular solution. When x is 1 and y is 4. Right? Now, let's see this. This can be written as y minus 3 is equal to x 3x plus 1 dy by dx. So in that case, I can therefore say that dx upon x 3x plus 1 is equal to dy upon y minus 3. Integrate both sides. Right? Now, I can say, let us assume that 1 upon x 3x plus 1 is a upon x plus b upon 3x plus 1 partial fractions, right? So in that case this will be 1 upon x 3x plus 1 is going to be a times 3x plus 1 plus b times x upon x 3x plus 1. So x and x gets cancelled, 3x plus 1 and 3x plus 1 gets cancelled. So 1 is equal to a 3x plus 1 plus bx, right? Now I want to make this bracket as 0. If I want to make this bracket as 0, you will say let us assume that x is equal to 1 by 3. If I take x to be 1 by 3, I will get 1 is equal to minus 1 by 3. Then 3 and 3 will get cancelled, minus 1 plus 1 0 is b into minus 1 by 3. Therefore you will get b is equal to minus 3. Similarly, I want to make the second bracket as 0, second term as 0. So you will say that let x be equal to 0. So in that case I will get 1 is equal to a 0 plus 1. Therefore a is equal to 1. So in that case you will get therefore integral of, if I split that, that can be written as a upon x. So that's 1 upon x plus b. b is minus 3 upon 3x plus 1 dx is integral of dy upon y minus 3. Split the integral. So this will be integral of 1 upon x dx minus 3 integral of 1 upon 3x plus 1 dx is integral of 1 upon y minus 3 dy. Now, integral of 1 upon x can be written as log mod of x minus 3. Integral of 1 upon ax plus b is nothing but 1 upon a log mod ax plus b is equal to log mod y minus 3. Since all the terms are in terms of log, therefore I'll have to write constant also in the form of log. 3 and 3 gets cancelled. In log, subtraction changes to division and addition changes to multiplication. So I can write this as log xc upon 3x plus 1 is equal to log y minus 3. Log and log gets cancelled. So you will get this as xc upon 3x plus 1 is equal to y minus 3. But they've given you that the value of x is 1 and y is 4. So I'll get 1 c is 3 plus 1 is equal to y minus y, that is 4 minus 3. So I'll get c upon 4 is equal to 1. Therefore c is equal to 4. Substitute this value of c back in the original equation. So I'll get 4x upon 3x minus plus 1 is equal to y minus 3 is the particular solution. Right? Next, let's see another sum. dy by dx minus x square is x square y. Find particular solution. When x is equal to 2 and y is equal to 4. Right, now let's see how do we solve this. You have dy by dx minus x square is x square y. Therefore I can say that dy by dx is x square y plus x square. Dy by dx is equal to x square y plus 1. So in that case you will get dy upon y plus 1 is nothing but x square dx. X together, y together, integrate. Right? So this is going to be nothing but log mod y plus 1 is nothing but x cubed by 3 plus c. But they have given you, but it is given to you that x is 2 and y is 4. So I'll get log 4 plus 1 is nothing but 2 cube, that is 8 by 3 plus c. So I'll get log 5 minus 8 upon 3 is c. Once you get the value of c, substitute the value of c back in the original equation. Therefore I can say log mod y plus 1 is x cube by 3 plus c. Log 5 minus 8 by 3 is the particular solution. Next, let's see another sum, guys. Y minus x dy by dx is equal to twice 1 plus x square dy by dx. Fine. Find particular solution. No, they haven't asked you to find particular solution in this sum. Right? Let's see how do we solve this sum. I can say y minus x dy by dx is 3 plus 3x square dy by dx. Therefore I can say that y minus 3 is 3x square dy by dx plus x dy by dx. Therefore you can say y minus 3 is x dy by dx common. So in that case you will get 3x plus 1, right? Now in which case you can say that 1 upon x 3x plus 1 dx is nothing but dy upon y minus 3 integrate. I think we've done something very similar to this, x 3x plus 1 y minus 3, right? It's only the difference is here the sum was given to you in different manner. It's exactly like the fifth sum now. If you look at the fifth sum, this is same. Integral of 1 upon x 3x plus 1 is equal to integral of dy upon y minus 3. The only thing was that the presentation was different. You have to make sure that you get the like terms together, right? You will get the same answer that you got there. The answer for this sum should be, I'm not solving this, it's like the fifth sum only. Log xc upon 3x plus 1 is equal to log y minus 3. Fine. Next, let's see another sum. Y minus x dy by dx is equal to y square plus dy by dx, right? And they will also ask you to find particular solution. Find particular solution when y is 2 and x is 1, right? Let's try to see the sum. The question is y minus x dy by dx is equal to y square plus dy by dx. Now take this dy by dx on the other side, so I'll get y minus y square is equal to x dy by dx plus dy by dx. You will get this as y 1 minus y is equal to x plus 1 dy by dx. Therefore you can say that dx upon x plus 1 is nothing but dy upon y 1 minus y, right? You got x together, y together, integrate, right? Now you will say that let us assume that 1 upon y 1 minus y is a upon y plus b upon 1 minus y. right? So in that case I can therefore say that 1 upon y 1 minus y is equal to a 1 minus y plus by upon y 1 minus y, right? In which case you will get 1 is equal to a 1 minus y plus by, right? Now I want to make the first bracket as 0, so you will say let y be equal to 1, so I'll get 1 is equal to b. Next I want to make the second bracket as 0, so you will say let y be equal to 0, so I'll get 1 is equal to a 1 minus 0, so a is 1, right? Therefore you can say that integral of dx upon x plus 1 is equal to integral of a upon y 1 upon y plus b upon 1 minus y, b is also 1 minus y dy. Partial fractions are done. Now split the integral. I will get therefore integral of dx upon x plus 1 is integral of 1 upon y dy plus integral of 1 upon minus y plus 1 dy. Integral of 1 upon x plus 1 dx upon x plus 1 is log mod x plus 1 is equal to log mod y plus 1 upon minus 1 log mod minus y plus 1. Since both the x and the y variable are in terms of log, therefore your constant should also be in terms of log. So I'll get log x plus 1 into c is going to be nothing but log y upon 1 minus y. Plus into minus, minus changes to division, right? So log and log gets cancelled. So I'll get x plus 1 into c is y 1 minus y, right? Once you have the differential equation, they've asked you to find out particular solution, but they've given you that y is equal to 2 and x is equal to 1. So in that case I can say 1 plus 1 into c is 2 upon 1 minus 2. 2c is 2 upon minus 1. 2 and 2 gets cancelled, c is minus 1. So therefore your solution, particular solution will be minus of x plus 1 is y upon 1 minus y is the particular solution. Right? Next, let's see another sum, guys. Now that was type 4. Let's move on to type 5. Suppose if they give you a sum, this was sum number 8. Let's see sum number 9. Y plus x dy by dx into sin xy is equal to cos x using xy is equal to b, right? That's the 5th type of sum. How will I identify that, guys? How will I identify that? In that they will tell you that a particular variable xy has to be substituted by some variable. That's how I'll identify the 5th type. Out of all the sums given in all the sums that we've done in this chapter, the remaining type sums are 3 marks. This is the only 4 mark sum that you will get from this chapter if you read the 5th type sum. How will I identify it? They will say using something as a variable. Okay. Now, the first thing that you do to solve this sum is whatever they ask you to use, differentiate that equation. Whatever they ask you to use, differentiate that equation. So in that case, they give you that xy is equal to v. Differentiate with respect to x. So I'll use uv formula, v derivative of u plus u derivative of v is dv by dx. So I'll get y plus x dy by dx is equal to dv by dx, right? Once you get this, then I can say that then I can say that leave that there as it is. You have the value of y plus x dy by dx is equal to dv by dx. So you can therefore say that x dy by dx is dv by dx minus y, right? In which case you will get therefore dy by dx is 1 upon x dv by dx minus y, right? So the basic purpose of using that equation was to get the value of dy by dx, right? Now once you have the value of dy by dx, they're giving you a particular equation and they've asked you to solve the equation. Now the equation is y plus x dy by dx into sin xy is equal to cos x. So in which case you can say y plus x dy by dx I just found out is nothing but 1 upon x dv by dx minus y sin xy. They've said that the value of xy is v is cos x. X and x gets cancelled, therefore I'll get y plus dv by dx minus y into sin v is cos x. Y and y gets cancelled, so you'll get dv by dx into sin v is cos x. Therefore you can say that sin v dv is cos x dx. I have v together, I have x together. Integrate. Integral of sin v is minus cos v. Integral of cos x is sin x plus c. We substitute the value of v. The value of v is nothing but xy. So you will get minus cos xy is sin x plus c. That will be your answer. So very simple, 4 marks. Whatever they ask you to use, you differentiate that equation first and then substitute, right? Let's see another sum. dy by dx is equal to x plus y plus 1 upon x plus y minus 1. Use x plus y is equal to u. Right? Now they've asked you to use x plus y is equal to u. First thing, whatever they've asked you to use, you will differentiate that. So I'll say differentiate with respect to x. D by dx of x is 1 plus dy by dx is equal to du by dx. Therefore I'll get dy by dx is equal to du by dx minus 1. Right? Once you have this, I'll say but they've given you that dy by dx is equal to x plus y plus 1 upon x plus y minus 1. dy by dx is given to you as du by dx minus 1. dy by dx you just found out this du by dx minus 1 is equal to x plus y can be written as u plus 1 x plus y u minus 1. So therefore you will get du by dx is equal to u plus 1 upon u minus 1 plus 1. The minus 1 goes on the other side. LCM du by dx is u plus 1 plus u minus 1 upon u minus 1 plus 1 minus 1 gets cancelled. So you will get du by dx is 2u upon u minus 1. Right? Cross multiply. You will get u minus 1 upon 2u du is equal to dx. Integrate, right? If I integrate, in that case I will get, split the numerator. So this will be integral of u upon 2u du minus integral of 1 upon 2u du is integral of dx. U and u gets cancelled, so this is 1 upon 2 integral of du minus 1 upon 2 integral of 1 upon u du is integral of dx, right? In which case I can say that 1 upon 2 integral of du is u minus 1 upon 2 integral of 1 upon u is log u, integral of dx is x plus c. Now resubstitute the value. If I resubstitute the value, I'll get 1 upon 2 x plus y minus 1 upon 2 log x plus y is x plus c, right? So when I open the bracket, this will be 1 upon 2x here and x on the other side. So that will be x minus 1 upon 2x. See guys, this will be 1 upon 2x plus 1 upon 2y minus 1 upon 2 log x plus y is x plus c. Now the plus 1 upon 2x, when I take it on the other side, it will become minus 1 upon 2. So I'll get 1 upon 2y minus 1 upon 2 log x plus y. X minus 1 upon 2x is 1 upon 2x plus c. That will be the answer for that, right? We will stop this here for the day. Thank you very much.